What if the Earth we know is only the latest draft of a story written and erased 1,000 times before? The continents beneath us move like restless ghosts, but the true silence lies deeper still, in the layers of rock where time no longer means what it used to. Every fossil, every crystal vein, every grain of sand tells us something, but also hides something greater. We say the dinosaurs ruled the Earth, but who ruled before them? Who breathed before the air turned kind? And what names have been lost to the wind? So before you get too comfortable, take a moment to like the video and subscribe. But only if you really like what I'm doing here. And tell me, where in the world are you listening from? And what time is it there? The story begins in a silence older than memory. Before the first roar of a reptile, before trees learned to rise toward the sun, the Earth was a half-lit dream. Molten seas rolling beneath a sky the color of rust. Continents still forming and breaking like brittle shells. The air would have burned our lungs. The ocean shimmered with metals, toxic and warm. Yet in that chaos, something stirred. Perhaps a chemical whisper. Perhaps a chance alignment of light and shadow. Life began not as a creature but as a tremor, a vibration on the skin of a sleeping planet. If we look back far enough, past the dinosaurs, past even the first fish, we reach an age so ancient it barely feels real. Scientists call it the Precambrian, but that word is too clean for what it was. An age of haze and fire, where oceans boiled under ultraviolet light and continents drifted like half-melted ice. For nearly 4 billion years, life remained invisible. Only traces remain. Stromatolites, layered mounds built by cyanobacteria that trapped sunlight in shallow seas. They are the oldest living fossils on Earth. Silent architects that once filled the air with oxygen and changed the planet forever. But even before them, there are signs of something stranger. In the oldest rocks of Western Australia, in greenstone belts over 3.5 billion years old, scientists found isotopic fingerprints that hint at early metabolism. Carbon ratios too subtle to be random. Were they the ashes of the first cells? Or only chemical illusions? If life was already thriving that long ago, where did it come from? Some believe it began in deep-sea hydrothermal vents, where minerals formed microscopic chambers like natural laboratories. Others imagine it arrived from elsewhere, on comets, meteorites, or cosmic dust. Seeds from a more ancient world. If that were true, then life on Earth would not be original, but inherited. The earliest oceans were thick with iron and methane. No blue sky yet, only a dim red glow filtering through the haze. The moon loomed closer, a silent witness to the birth pains of a planet. Volcanoes breathed carbon into the air, and lightning ignited chemical reactions that danced across the waves. Somewhere in that glow, molecules began to assemble themselves. They twisted, split, merged again. Patterns began to repeat. A rhythm was found, like the first heartbeat of time. Yet every discovery we make about this forgotten Earth opens another question. How much of it is real, and how much is guesswork stitched into missing years? The geological record from those early ages is broken, melted, and rewritten by pressure and fire. It's as if the planet wanted to hide its childhood, erasing itself layer by layer. What we see today are only fragments of that first dream. Zircon crystals older than continents, pieces of crust that survived endless recycling. Some scientists even suspect that before our known continents others existed. Worlds like Kenorland, and Columbia, each forming, drifting and dying long before Pangea was ever imagined. It's hard to picture a world without green, without roots, without sound. But perhaps it was not silent. Perhaps the sea itself sang, waves striking newborn shores, the slow pulse of tides pulled by a closer moon. There were no eyes to see, no ears to hear, yet still the earth moved as if aware of its own becoming. When we speak of time before the dinosaurs, we often imagine emptiness. But this emptiness was alive in ways we cannot grasp. Microbial mats spread across the seabed like alien carpets. Sulfur-eating bacteria thrived in chemical darkness. The atmosphere shifted between death and possibility, each change bringing both creation and ruin. To live was to endure transformation. Some researchers have proposed that early Earth may have been struck by catastrophic impacts long after life began, enough to boil the oceans and sterilize the surface. If so, life must have retreated underground, waiting for centuries in the pores of rock, then returned once the world cooled. That would mean we descend not from creatures of sunlight, but from survivors of darkness. The Earth, too, has memory in its scars. But how many times did this cycle happen? Creation, destruction, renewal. There may have been entire ecosystems that left no trace, worlds erased by heat and pressure. Fossils melted before they could form. The first civilizations of cells buried under mountains that no longer exist. Perhaps that is the true secret of the pre-dinosaur Earth, that it was not empty, but forgotten. In the end, all we can see are echoes, the faint chemical signatures of life's first breath, the oldest rocks, whispering of oceans long gone, every fossilized ripple, every layer of ironstone, every pattern of isotopes is a page from a book that burned, leaving only its ashes pressed into stone. We can reconstruct fragments, yes, but the full story remains hidden beneath the surface, waiting for someone who can read silence. And maybe that's the point. Perhaps Earth's earliest history was not erased by accident. Perhaps forgetting was necessary, a cleansing before memory could begin. After all, if life is a repetition, maybe it must start again each time the world grows too certain. When we close our eyes and imagine those ages, it feels less like history and more like myth. A tale told by rocks to those who can dream slowly enough to hear. The forgotten Earth lies beneath us still, breathing through fault lines, murmuring through magma, alive in the quietest ways. Somewhere, deep below the continents, the last trace of that first ocean still moves, hidden in the mantle, carrying whispers of a time before time. But if the Earth has rewritten itself this many times, how can we ever be sure this version, ours, will be the last? The continents do not stay still. They drift, collide, and scatter, as if remembering and forgetting each other over and over again. Today, we call them by names that seem eternal: Africa, Asia, America. Yet each is only a temporary arrangement in the long breath of time. Long before the age of the dinosaurs, before jungles and feathers and scales, the Earth's face looked nothing like it does now. It was a single vast body, one continent, one ocean, one silence. They called it Pangaea. But even Pangaea had ancestors, ghosts of older supercontinents that came and went like forgotten gods. Rodinia, Columbia, Kenorland, Each world was born, broken, and buried beneath the next. The idea that continents move was once considered madness. In the early 20th century, Alfred Wegener suggested that the continents had once fit together, like pieces of a torn map. He was ridiculed. Rocks, they said, do not drift. But the Earth kept proving him right. In magnetic patterns frozen into the ocean floor, in the mirrored shapes of coastlines across oceans, in the fossils of identical creatures found on lands now oceans apart. Wegener never lived to see his vindication. The plates were real. The planet was alive, and movement was its nature. Imagine standing on the edge of that primeval landmass. The horizon would have curved in unfamiliar ways. The interior was vast, dry, and endless, deserts stretching farther than sight. The coasts were fringed by stormy seas, heavy with salt and metal. To the north, glaciers sometimes crept down from highlands. To the south, volcanoes burned through crust still young and restless. There was no border between life and fire. Everything was still learning what it meant to endure. Yet this was not the first time the continents had met. Before Pangaea, another world existed, Rodinia, nearly 1 billion years earlier. Scientists believe it formed around 1.1 billion years ago, when fragments of crust collided and fused into a single supercontinent surrounded by a global ocean called Merovia. For hundreds of millions of years, Rodinia endured, until heat and motion tore it apart again. The pieces drifted across the seas, gathering into new forms. First Pannotia, then Gondwana, and eventually Pangaea. Each one the echo of the last. If the Earth has created and destroyed its own face so many times, then what else has it buried with it? We find mineral scars in the mantle that suggest ancient subduction zones, places where entire oceans were swallowed, leaving behind chemical ghosts. Scientists call them deep mantle anomalies, strange signatures of rock older than the continents above them. It is as if the planet keeps its memories folded inside itself, inaccessible, but still pulsing. Perhaps that is why each geological cycle feels like a rebirth. When Rodinia broke apart, the Earth entered one of its coldest ages, the Cryogenian, when glaciers reached the equator and oceans froze over completely. They call it Snowball Earth. It was a time of near extinction, yet somehow, from that silence, life survived and diversified. When the ice finally melted, the world flooded with nutrients, and evolution exploded. Could it be that every breaking of the continents brings both death and awakening, destruction as a necessary gesture toward renewal? The rocks suggest so. Each continental merger coincides with upheaval, mass extinctions, oxygen shifts, volcanic winters, but also with creativity, new species, new patterns, new experiments in the architecture of life. Perhaps Earth's history is not a straight line of progress, but a spiral. Rising, collapsing, and rising again, always circling closer to complexity. During Pangaea's height, around 250 million years ago, the world was a single land surrounded by the vast ocean Panthalassa. Winds circled the globe unbroken. Deserts dominated the interior, while the coasts swarmed with early reptiles, amphibians, and forests of strange trees. But before the dinosaurs, the ecosystem was already fragile. The joining of all continents disrupted ocean circulation, trapped heat, and poisoned the air. Beneath the crust, volcanic provinces, like the Siberian traps, released enough carbon to suffocate the seas. This was the beginning of the Great Dying, the worst extinction in Earth's history. From unity came collapse. Some scientists wonder if Pangaea's formation itself was the trigger, that the act of becoming one sealed its fate. When continents merge, mountains rise, but weathering slows. Carbon remains in the air longer, temperatures rise, and life begins to falter. The same process that unites also destroys. Every perfect circle, it seems, carries its own fracture. Even now, if you look at the edges of continents, the scars of their separation, you can see the ghosts of that ancient closeness. The coast of Brazil mirrors the curve of West Africa. Fossilized ferns of the genus Glossopteris appear on both continents, their spores once scattered by the same wind. The Appalachian Mountains of North America are the broken continuation of the Caledonian Range in Scotland and Scandinavia. peaks that were once part of a single chain. The Earth still remembers the shape of its unity, even as it drifts apart. What would it mean then if these cycles were not accidents of geology, but the rhythm of something deeper, a kind of planetary respiration? Expansion, contraction, birth, dissolution, like lungs inhaling oceans and exhaling continents. Some geophysicists even speculate that Earth might be self-regulating over immense timescales, that tectonic motion, volcanism, and carbon exchange form a feedback system maintaining the delicate balance of habitability. In that sense, the continents are not merely stone. They are the body of a living world, reshaping itself as it dreams. But every living thing forgets. Each time the continents reunite, the evidence of the last world is buried beneath the next. Fossils crushed, sediments subducted, memories turned to magma. The deeper we dig, the more the story dissolves into molten ambiguity. The earliest supercontinents leave almost nothing behind, only isotopic whispers, traces of zircon crystals that survived the fire. We can measure them, date them, even model their arrangement, but the picture remains blurred. We are archaeologists of a planet that refuses to remember itself, and maybe that's why the idea of Pangaea feels mythic. Not just a geological event, but an echo of something we all carry inside. The longing to return, to be whole again, to find the place where everything was once connected. Perhaps we sense it because we are made of that same matter, recycled from the bones of old worlds. Each breath we take contains atoms forged in volcanoes that rose from Rodinia's death. Each grain of soil beneath our feet carries the ashes of continents that drifted before we had names. If there have been so many Earths before ours, how many will follow? The continents are still moving, slowly but surely. Millions of years from now, another supercontinent will form. Pangaea Proxima, or maybe Novopangaea. The oceans will narrow, the climate will change again, and life will be forced to adapt once more. The same rhythm will continue, indifferent and eternal. But the deeper question lingers. In those buried cycles, could something more than land have been erased? Cultures of microorganisms, networks of intelligence, traces of pattern and consciousness older than evolution itself. When the crust melts and reforms, what else vanishes besides stone? Somewhere in the tectonic hum of the planet, there is a heartbeat we no longer hear. It is not the sound of destruction, but of memory folding in on itself. The continents will meet again, as they always have. But by the time they do, will there still be anyone left to remember that they were ever apart? Before the first foot pressed against dry earth, before wings and bones and claws, life belonged to the sea. The ocean was the first sky, the first city, the first experiment. Everything we know of movement, hunger, and awareness began there. Yet the ocean of that ancient time, long before the dinosaurs, was not the blue cradle we imagine. It was a darker, heavier place, a kingdom of shadows where life groped forward without eyes, without sound, without light. If one could drift there now through its heavy waters, it would feel less like a home than like a dream still learning how to wake. The fossils of that world do not speak easily. The creatures of the early seas were soft, fragile, easily erased. But in certain rocks, black shales, fine muds preserved in oxygen-starved depths, the impressions of strange beings remain. Long, ribbon-like bodies with spines of light, discs that might be mouths, segmented ghosts with tendrils and flaps instead of fins. They belong to a time around 540 million years ago, the Cambrian period, when life suddenly bloomed as if the planet itself had inhaled. They call it the Cambrian explosion, a moment when complexity erupted out of simplicity, when nature invented eyes, shells, legs, and teeth in a geological instant. But explosions have causes, and this one does not. No one truly knows why life accelerated so violently. Some point to rising oxygen levels after the great glaciations of the Snowball Earth, others to the appearance of new predators, forcing adaptation through fear. There are those who whisper that evolution itself might have crossed a threshold, that life discovered information and began to rewrite itself consciously. What if it wasn't merely biology, but memory awakening? Among the earliest marine creatures were the trilobites, armored wanderers of the seafloor whose eyes were made of crystal, literally carved from calcite. Their sight was the first to fracture light beneath the waves. They thrived for 270 million years, longer than any mammal or dinosaur, and then vanished completely. Their fossils cover every continent, like scattered pages of an ancient record. Some are so finely preserved that the structure of their compound lenses still refracts light under a microscope. Each tiny lens, hundreds of them per eye, is a fossil of perception, frozen in stone. And yet even the trilobites were latecomers. Before them, there was another age, stranger still, the Ediacaran world. In the rocks of Australia, Namibia, and Newfoundland, scientists have found imprints of beings that defy all classification. Some look like leaves, some like quilts of light, some like ripples left by vanished rain. Dickinsonia, Charniodiscus, Sprigina, names that try to contain what we cannot understand. Were they animals, fungi, giant colonies of cells, or something from a forgotten branch of life, erased before it could evolve further? Their bodies left no bones, no mouths, no clear organs, only the suggestion of form. When oxygen rose and predators appeared, the Ediacaran beings disappeared. It was as if a curtain had fallen between two acts, soft shadows replaced by shells, stillness replaced by movement. The Cambrian explosion was not only creation, it was extinction too. Every invention of nature required the death of another. The ocean, in its hunger for variety, consumed its own past. If you were to stand beside those ancient seas, you would not have seen color. Light barely penetrated their depth. The sun's warmth filtered through clouds of iron, dust, and sulfur. The water carried no sound but the hiss of bubbles, the trembling of chemical tides. And yet within that dim silence, everything began to take shape. Tiny planktonic creatures, ancestors of all animals, swam with simple strokes. Worms burrowed through mud, mixing oxygen into the seabed for the first time. The sea was becoming self-aware. Paleontologists who study the Burgess Shale in Canada often speak of it with reverence, as though describing a sacred text. There, within dark layers of shale laid down 500 million years ago, are creatures that seem drawn from hallucination. Anomalocaris, with twin grasping arms and a mouth like a circular saw. Opabinia, with 5 eyes and a nozzle-like appendage for feeding. Hallucigenia, a worm that once confounded science because its fossil was accidentally reconstructed upside down. These beings were the prototypes of possibility, experiments in form that nature later abandoned. The Burgess Shale is a miracle not because it preserves beauty, but because it preserves confusion. Every fossil found there rewrites the family tree of life. Some have features that link them to no known lineage. Others seem to suggest entire phyla that rose and fell before history began. It is as if life itself rehearsed countless versions of itself before deciding which would endure. And we, the observers, the descendants of survivors, can only guess which branches led to us. But perhaps the most haunting truth of these early seas is not what they reveal, but what they hide. Beneath the sediment of shallow Cambrian waters, there are older layers we cannot reach. melted, or metamorphosed beyond recognition. We know life existed before the explosion, yet we can hardly see it. Every attempt to peer further back ends in uncertainty. Did evolution truly explode, or did we simply lose the evidence of what came before? Some scientists now believe the apparent suddenness of the Cambrian was an illusion, the result of missing strata, vanished by erosion, or hidden deep in the crust. If that's true, then our narrative of life's dawn is built upon a gap, a missing chapter mistaken for a beginning. What other beginnings might lie before it? In Greenland, in 3.7 billion-year-old rocks, faint traces of stromatolite structures suggest microbial communities older than any known fossil record. They lived, died, and built reefs when the moon was closer and the days were shorter. In the Isua Greenstone Belt, chemical evidence of life may stretch even further back, though the rocks themselves have been folded and cooked by eons of heat. We are left with ghosts of signatures, whispers that something alive once stained the stone. Life's story, then, is not a straight ascent from simple to complex, but a palimpsest, an overwritten manuscript where new words are written over old ink and the faint traces of the erased can still be seen. Perhaps the Cambrian explosion wasn't a beginning, but a remembering, a reawakening of forms buried in the deep memory of the planet. We tend to imagine prehistory as silence, but maybe it was more like music played beyond our hearing. Frequencies too low, too slow. In those ancient seas, life was composing itself, experimenting with rhythm and structure, with repetition and variation. It was writing the first symphony of movement. Even now, the ocean keeps its secrets. There are fossils yet undiscovered, entire biomes still hidden beneath continental shelves. And in the deep sea, those lightless trenches that resemble the world before light, new forms continue to appear, as though the past is not gone but sleeping, waiting to be recognized again. If Earth once rehearsed 1,000 ways of being alive before settling on the forms we know, how many rehearsals still remain? How many versions of life are still dreaming beneath the tides, in the same shadows where it all began? Beneath the stillness of the ocean, fire never sleeps. The crust that carries the weight of water is thin, thinner than the walls of a shell, and under it lies a world that burns. Long before dinosaurs, before even forests or wings, the planet's heart beat violently in the dark, shaping everything that lived above it. The sea we imagine as calm was then a restless skin stretched over fire. It hissed and shivered, cracked and healed again. Every ripple above was mirrored by a fracture below. The earliest Earth was more violent than we can bear to picture. Volcanoes rose like open wounds along the seafloor, spilling iron and sulfur into water that steamed and boiled. Black smokers, towers of mineral smoke, poured chemicals into the abyss, clouds that shimmered in the darkness like underwater storms. Around them, something impossible happened. Life gathered. Tiny organisms fed not on sunlight but on heat, on metal, on poison. They built entire ecosystems around these vents, surviving in places where life should have been forbidden. Some scientists believe this was where life began, in the cracks where ocean met magma. There, within microscopic chambers in rock, molecules could hide from chaos, replicate, and grow. The energy gradient between hot and cold water created natural engines, primitive metabolisms. The Earth's breath became the first spark of awareness. It is a poetic thought, but perhaps a true one, that life began not in sunlight, but in darkness, not in peace, but in pressure, not in beauty, but in fire. When we study these deep-sea vents today, we find creatures that seem unchanged for hundreds of millions of years. Worms with no mouths, shrimp with eyes that sense heat instead of light, bacteria that metabolize sulfur. They are relics of the planet's first bargain with survival. Even now, they live by the same rule that began everything: transformation through adversity. To live is to use what burns against you, but fire is a fickle ally. The same volcanic pulse that nourished the ocean also brought catastrophe. Throughout prehistory, immense eruptions reshaped the world again and again, sometimes erasing nearly all that had come before. The rocks record these apocalypses in layers of ash and lava, silent signatures of destruction. Around 252 million years ago, the greatest of them all unfolded: the Siberian Traps eruption, releasing more lava than the surface of the United States, poisoning the air with carbon dioxide and methane. It heated the planet until the oceans turned acidic, suffocating nearly every living thing. They call it the Permian Triassic extinction, the Great Dying. 95% of marine life vanished. It was fire beneath the waves that ended one world and began another. But even before that, smaller burnings had already reshaped life many times. In the Ordovician period, volcanoes ignited a chain of events that drew carbon from the air and plunged the Earth into ice. Later, massive eruptions near what is now India darkened the skies and altered the chemistry of the seas, driving species to extinction. Each time, the planet seemed to test how far it could go before silence took over. And yet, life always returned. Not the same, but stronger, stranger. It seems that the Earth itself uses disaster as a form of memory, a way to renew what has become stagnant. Volcanoes open the crust not just to destroy, but to recycle. They release minerals that feed plankton. They sculpt islands that become new habitats. They thicken the air with the gases that plants will one day breathe. The line between ruin and creation blurs until it disappears. In a sense, Earth's entire history is written in the language of subduction and eruption. Continents dive beneath one another. Magma rises, cools, and becomes new crust. The cycle is endless. We live upon a skin that is constantly replaced. Every mountain once molten, every ocean floor younger than it appears. The oldest seafloor on Earth is barely 200 million years old, younger than the first dinosaurs, because it is continuously consumed and renewed. Beneath the waves, the planet is always rewriting itself. Imagine it from below. A network of fiery ridges circling the globe like veins of light. Magma flows outward from the mid-ocean ridges, hardens, and drifts apart, dragging continents with it. The seafloor spreads by inches each year, yet over eons, that slow movement rearranges entire worlds. The continents are passengers, drifting on rivers of molten rock. When they collide, mountains rise. When they part, oceans open. The sea and the fire beneath are never separate. They are one breathing organism, exhaling water, inhaling stone. Geologists studying the chemical signatures of ancient basalts have discovered something peculiar. Certain isotopic ratios appear that do not match the composition of modern mantle rocks. They come from deeper, older reservoirs, remnants of Earth's first crust, buried for billions of years. In other words, the planet still carries fragments of its original self, melted but not forgotten. They rise occasionally through volcanic plumes, like memories surfacing through dreams. What if the same principle applies to life? If rock can remember, can biology? Some microorganisms living near hydrothermal vents today have genes that trace back almost unchanged to the earliest branches of the tree of life. They are living fossils, descendants of cells that may have survived multiple planetary resets. In their simplicity lies endurance. Perhaps they are the true rulers of Earth, silent, ancient, patient, The ocean floor also hides stranger secrets. In some regions, thick layers of methane hydrate, frozen gas, lie trapped beneath the mud. When disturbed, these hydrates can release enormous bursts of methane, altering the climate in catastrophic ways. Some researchers have proposed that such events might have triggered past mass extinctions, sudden warmings that suffocated the oceans. Fire, it seems, can rise even from ice. If we could listen to the ocean's deepest places, we might hear the low tremor of the mantle beneath. A sound too deep for human ears. A slow heartbeat. Each earthquake, each eruption, is a pulse in that rhythm. The same heat that once forged life now sustains it in the dark. The abyss is not a grave. It is a womb that never cooled. But for all our study, there remains a silence we cannot break. A geological amnesia. Most of the early seafloor has been recycled, swallowed back into the mantle. The first record of oceans, volcanoes, and vents is gone, melted into anonymity. We can only infer their existence from chemical shadows in ancient zircons, from the isotopic breath of long-lost eruptions. It is as if the planet deliberately erased its own origin story, leaving us with fragments too incomplete to reconstruct. Perhaps it must be that way. Fire does not preserve, it transforms. What began beneath the waves was never meant to remain. The life that crawled from those vents, the continents that rose from their ashes, all carry that same principle within them. Nothing endures, only changes. Tonight, as the earth turns and the ocean glows faintly under the moon, the fire still burns below. Somewhere under the Pacific, magma flows silently through cracks, unseen yet constant, the same fire that shaped the first world. We call it geology, but maybe it's closer to memory. The oldest kind, the one that doesn't speak, only burns. And if the planet has always needed fire to begin again, what does that say about us? The creatures built from its ashes. Will we too have to burn before we can change? There was a time when life had no bones, no shells, no eyes, only form. A time when the living and the non-living were not yet separate, when existence itself was soft, silent, and luminous. The Ediacaran world, they call it now. A chapter so distant it feels less like history and more like a half-remembered dream. It came before the Cambrian seas erupted with movement, before the first predator opened its mouth. This was the age of stillness, of creatures that floated or rested on the seafloor like slow, breathing leaves. In that long twilight, between 635 and 541 million years ago, the Earth was recovering from its deepest sleep. The Snowball Earth, a frozen world that stretched glaciers to the equator, had finally begun to thaw. Water returned, the air thickened with carbon dioxide, and sunlight touched the oceans again. The thaw brought chaos, but also possibility. The atmosphere changed, the chemistry of the seas evolved, and out of this fragile calm emerged the first beings large enough to be seen with the naked eye. They did not look like us, or like anything that came after. Some were flat, fern-shaped impressions fanned across the seabed. Others resembled medusas, discs that pulsed with faint symmetry. There were creatures like ribbed cushions, like quivering veils, like patches of living skin spread over the mud. They left no skeletons, only faint imprints pressed into fine sediments, the fingerprints of another mode of being. Among them was Dickinsonia, an oval life form with repeating segments, its soft body imprinted like the pattern of a ripple. For decades, scientists could not decide what it was: animal, fungus, or something else entirely. But in 2018, traces of cholesterol molecules were found in its fossilized remains, the signature of animal life. Dickinsonia, it turned out, was one of us. Or perhaps we are one of it. Nearby in time and stone were others. Sprigina, with its mirrored body plan suggesting the first hint of bilateral symmetry. Charniodiscus, anchored to the seafloor by a slender stalk, waving leaf-like fronds in the current. Kimberella, which grazed microbial mats with a rasping mouthpart, an ancestor perhaps to snails. Yet even with these clues, their world remains alien. There is no clear food chain, no record of predation, no trace of struggle. It is as though life had not yet learned the concept of fear. The Ediacaran biota are preserved in only a few places on Earth. The Flinders Ranges of Australia, the White Sea of Russia, the cliffs of Newfoundland. Each is a window into a vanished stillness. Fossils lie like shadows, pressed into ancient seafloor that hardened into stone. When researchers brush away the dust and reveal those soft outlines, they are not merely studying organisms. They are touching the first gesture of complexity. But this world did not last. Around 541 million years ago, almost all of these forms disappeared. The boundary between the Ediacaran and the Cambrian is sharp, as if someone turned a page. The oceans that once held quiet gardens of soft bodies became arenas of motion and violence. Teeth appeared, shells hardened, eyes opened. The soft forms could not compete. Their time ended as abruptly as it began. What happened to them? Some think rising oxygen allowed faster, stronger animals to evolve. And the Ediacaran forms, adapted to low-energy life, were consumed or outcompeted. Others suspect a shift in the chemistry of the ocean, a new kind of sediment that no longer preserved soft bodies. There are even hypotheses that they represent an entirely different experiment in multicellularity, a branch of life that led nowhere, erased by evolution's next attempt. If that were true, then the Ediacaran world was not merely a prelude to ours, but a separate genesis, a failed universe of life. It is haunting to imagine a biosphere with its own logic, its own rhythm, extinguished not by catastrophe, but by change. The stones remember it only faintly. In the silence of that lost ocean, one can almost hear the breathing of the planet itself. The water would have glowed faintly under a red sky. The land was barren, continents covered in microbial crusts, black and green films that shimmered with dew. There were no forests, no sound of insects, only the low whisper of wind against naked rock. The largest living thing was no larger than a pillow, yet for the first time, size had meaning. Life was learning to shape space. Some researchers, like Adolf Seilacher, proposed that Ediacaran organisms were not animals at all, but a now extinct kingdom, Vendobionta, creatures that fed by absorbing nutrients directly through their bodies, like living membranes. If true, they may represent an entire lost experiment in how to be alive. A way of existence so unlike ours that even the word organism may not apply. What if that world still lingers, unseen? In the deep sea, in microbial mats beneath the crust, in chemical gradients where time moves slowly enough for the past to persist. Life does not forget easily. It hides its ancient faces in the corners of new forms. Some jellyfish still glow with Ediacaran geometry. Some lichens pulse with the same slow metabolism. We may carry their echo in our cells, the memory of being soft, of breathing without fear. The more we learn, the stranger the picture becomes. Trace fossils, faint grooves and burrows in the sediment, suggest that some Ediacaran creatures could move. But their movement was slow, almost imperceptible, measured in millimeters over days. They left behind looping tracks like thought patterns frozen in stone. It was as if the ocean floor itself was thinking, and perhaps it was. The Ediacaran period sits at a threshold, the point where matter began to behave as if it were aware. The line between chemistry and consciousness was still blurry. To exist was to drift, to pulse, to sense light through the skin. The Earth was dreaming of movement, of hunger, of choice. Then came the awakening, the Cambrian explosion, the sudden acceleration of complexity that shattered the calm. The soft gardens were torn apart, replaced by shells, spines, and predators. The era of gentleness ended. But without that quiet prelude, perhaps the later symphony could never have begun. If one were to stand now on a cliff in South Australia at dusk, where the red rocks hold those delicate imprints, it might seem as though nothing moves. Yet beneath your feet, within the stone, are the ghosts of a world that breathed without sound. You could trace a finger over a fossil and feel the texture of something that once shimmered alive before bones, before fear, before form had names. We look at those shapes and call them primitive, but maybe we are the crude ones, the noisy descendants of a silence we can no longer understand. Perhaps the Ediacaran world was not a failed experiment, but a success of a different kind. A moment when life was content to simply be, without the burden of teeth or time. Still, the question lingers in the sediment. Where did they go, those giants without bones? Were they erased by evolution, or did they retreat into the unseen, waiting for a gentler age to return? The sea keeps its secrets well, and sometimes, late at night, when the water is perfectly still, it seems to remember their shapes. Before the air became blue, it was poison. Thick with methane, carbon dioxide, and volcanic haze, it shimmered like a veil of glass above an ocean the color of metal. To breathe then was to drown. To exist was to endure suffocation. Yet in that uninhabitable air, something miraculous was forming, the slow invention of breath itself. Long before lungs, before gills or leaves, invisible architects were rewriting the sky. They were small, almost nothing at all, yet their work would change everything that followed. They were cyanobacteria, ancient, single-celled organisms that learned to eat light. Drifting in shallow seas, they absorbed sunlight through simple pigments and released something utterly alien to the early Earth: oxygen. At first, it was a byproduct, an accident of metabolism. But that accident transformed the planet forever. The Great Oxygenation Event, they call it. One of the most profound revolutions in the history of life. It happened around 2.4 billion years ago, long before dinosaurs or even the faintest whisper of multicellular creatures. The air we breathe today, every sigh, every storm, every flame, is their legacy. Yet their success nearly killed everything else. The early world's organisms had evolved to thrive in an oxygen-free environment. To them, oxygen was corrosive, deadly. It attacked their delicate chemistry, burned through their cells like acid. When cyanobacteria began flooding the atmosphere with it, it was not a gift, but a catastrophe. The oceans rusted, turning red as iron reacted with the new gas. Methane levels plummeted. The planet cooled, perhaps even froze. Life's first apocalypse arrived not from fire, but from breath. The record of that disaster lies in the rocks. Banded iron formations, ribbons of red and gray that stretch across continents. Each layer marks a pulse of oxygen, each band a heartbeat of the planet's transformation. For millions of years, oxygen built up slowly, absorbed by minerals and the sea. Only when those sinks were full did it begin to accumulate in the air. The sky that had once glowed copper turned pale, then blue. Lightning flashed across a new kind of atmosphere, striking waves rich with nitrogen, creating molecules that would feed future life. But imagine what it felt like for the world to change its breath. Whole ecosystems vanished. Anaerobic microbes retreated into the mud, the deep crust, the shadows where oxygen could not reach. Some survived, becoming extremophiles, living fossils of a world that preceded air. Others perished entirely, erased by the very chemistry that had created them. The Great Oxygenation Event was not just a beginning. It was a mass extinction, one of the first. Creation and annihilation braided together, inseparable. And yet, without that death, there would be no us. Oxygen became the fuel for energy-rich metabolism, allowing life to grow larger, move faster, think deeper. It was the key that unlocked complexity. Every breath we take repeats the same act those ancient microbes began, turning sunlight into possibility. To inhale is to echo their first photosynthesis, to continue their work across billions of years. But oxygen alone did not shape the new world. Lightning played its own quiet part, that unpredictable fire that stitched the sky to the sea. In laboratory experiments in the 1950s, Stanley Miller and Harold Urey recreated early Earth conditions: water, methane, ammonia, hydrogen, and electricity. Within days, the liquid turned brown. When they analyzed it, they found amino acids, the building blocks of life. From lightning, chemistry became biology. It was as if the sky itself had spoken the first word. Of course, Miller's experiment was only a model, a shadow of what might have been, but it reminds us that energy, whether from the sun, from lightning, or from the deep vents of the ocean, has always been the midwife of creation. The Earth was a laboratory, and time was its patient scientist. Still, the paradox remains. How could life survive the world it changed? Some scientists believe that oxygen levels fluctuated wildly for hundreds of millions of years after the first rise, climbing, collapsing, and climbing again. The air was unstable, the climate unpredictable. It's possible that early life endured repeated near extinctions, suffocating and reviving in cycles, each wave leaving behind only the most adaptable survivors. Evolution may not have been a steady ascent, but a heartbeat. Expansion and contraction, creation and forgetting. Even the very air we know was not born in one moment, but through patience. It took over 1 billion years for oxygen to reach levels sufficient for complex animals. That long delay, called the boring billion by geologists, was anything but boring. Beneath its surface, the foundation of everything we know was being laid. Mitochondria, the energy centers of our cells, evolved from symbiosis between ancient bacteria. Multicellularity began to whisper its first designs. The atmosphere was preparing for the future, even as the planet seemed asleep. If we could travel back to that era, the sight would be both beautiful and terrifying. The sun would rise over purple seas. The sky would shimmer with auroras as excess oxygen met ultraviolet light. The land, still barren, would smoke with volcanic breath. The air would taste metallic. No creature could have survived above water. And yet, beneath the waves, the architects worked tirelessly, unseen, turning chaos into balance. In Greenland and South Africa, geologists have found sulfur isotopes that mark the exact moment when oxygen began to matter. A thin line in the stone dividing two worlds. Below it lies the alien Earth, the one without air. Above it, the beginning of ours. It's humbling to think that everything we call civilization, fire, language, thought, depends on that invisible molecule, on that ancient betrayal of the anaerobes. But what if oxygen was not just chemistry? What if it was a kind of consciousness spreading through matter, the planet's first realization of itself? For with oxygen came light, and with light came vision. The ocean grew transparent. For the first time, eyes evolved to see. Awareness followed clarity, and clarity required air. In giving us breath, the cyanobacteria may have given the earth perception. There's a strange poetry in that. The same molecule that fuels our blood also rusts iron and feeds fire. It is both life and destruction, always balanced on the edge of transformation. Too little, and the world suffocates. Too much, and it burns. Perhaps every living thing carries that same tension. The need to balance between creation and ruin. When we breathe, we do not think of the cost. But somewhere deep in our cells, the memory remains of oceans turning red, of lightning carving the first molecules of life, of the long patience of microbes that reshape the sky. Their story is written in our lungs, in every spark of energy that keeps us alive. And so, when the wind moves through the trees or the waves break in rhythm, perhaps what we're hearing is not mere weather. Perhaps it is the sound of the planet continuing to breathe, slowly, dangerously, beautifully, as it has since that first light struck water and turned poison into air. The miracle of oxygen was not that it created life, but that it taught life to endure its own consequences. And in that endurance lies the oldest wisdom of all. Every breath is both a beginning and an ending. There was a time when the sky was not blue but red, a dim, copper-colored haze stretching from horizon to horizon, glowing faintly even after sunset. It was not a sky meant for eyes, for there were none to see it yet. This was the world before the clarity of air, before oxygen turned the heavens transparent. In that long, alien dawn, the earth breathed methane, and the sun's light scattered through dust and gas like the glow of a dying ember. Everything shimmered, yet nothing was clear. If one could have stood on the shore of that primeval world, it would have felt both heavy and hollow. The air would cling like oil to the skin. The scent, acrid, metallic, and sweet with sulfur, would burn in the lungs. The sea would appear dark, its surface slick and slow, reflecting a sun filtered through a thick orange veil. It was a planet that felt half awake, still learning what light was. The rocks remember this era through color. The oldest sediments, banded iron formations and red beds, carry the mark of a sky once rich in methane and iron dust. In those days, the balance between chemistry and sunlight was delicate. A single change in atmosphere could shift the entire palette of the world. The red tint came from light scattering off methane molecules, much like the way a sunset now paints the evening sky crimson. But then, the red never faded. It was not a moment. It was a state of being. Some geologists call this time the Archean twilight, a period that lasted billions of years. It was the world before the oxygenation, before clarity. The warmth of the red sky may have kept the oceans from freezing under a fainter sun, a paradox known as the faint young sun problem. The sun's light was weaker than today, yet somehow the planet stayed warm enough for liquid water. The greenhouse gases, especially methane, trapped heat like a blanket, turning what should have been an ice-bound desert into a womb of storms and tides. It is strange to think that without that haze, without that blood-colored sky, life might never have begun. The very gas that would later become poison was, at first, protection. Methane and carbon dioxide wrapped the earth like amniotic fluid, nurturing the first cells in their fragile infancy. The sky's redness was not a warning, but a lullaby. But beauty in nature is rarely stable. As cyanobacteria filled the air with oxygen, the red world began to fade. Oxygen destroyed methane, oxidized minerals, and cleared the haze. The air became thinner, clearer, and blue for the first time. To us, that might sound like progress. But to the organisms of that age, it was apocalypse. The red sky was their world, and when it died, so did most of them. The blue sky was born from extinction. In some ways, the transformation from red to blue mirrors the human condition. Clarity gained only through loss, vision purchased by the price of forgetting. The world became visible, but in doing so, it became crueler. The veil was lifted, but the warmth was gone. Still, traces of that earlier world persist. When we look at Mars, its atmosphere thin, its sky tinted pinkish red, we see a reflection of our own past. Mars is the fossil of Earth's youth, a planet that never completed its metamorphosis. Once, it too may have had seas and a thicker air, but its core cooled, its magnetic shield weakened, and the solar wind stripped it bare. What remains is a red silence, a memory of what our planet might have become had it not learned how to breathe. And perhaps that is why the color red haunts our myths, the color of blood, of birth, of sunset and war. It is older than we are. It is the color of our first sky, buried deep in the collective memory of life itself. When our ancestors looked at fire and saw both warmth and danger, perhaps they were remembering, dimly, the time when the world itself burned with that same hue. The Earth's red sky was not uniform. Over volcanic plains, it deepened to rust, thick with ash and sulfur. Over the sea, it glowed faintly gold as sunlight diffused through haze. At night, the stars were dim, their light scattered before reaching the surface. The moon, newly formed and closer then, loomed enormous and pale in the tinted sky. Its reflection on the ocean looked like blood poured into ink. It was beautiful, but in a way that made silence feel eternal. Some scientists speculate that early life evolved pigments not for photosynthesis, but for protection. Shields against ultraviolet light filtered imperfectly by the red haze. These pigments may have been the ancestors of chlorophyll, the green molecule that would later paint the world's forests. If so, then green, the color of vitality, was born as a defense against red, a reaction to danger. Nature, it seems, creates by opposing itself. We tend to imagine evolution as a chain, but it is more like a negotiation. For billions of years, life and atmosphere argued in chemical whispers. Methane built warmth. Oxygen broke it down. Volcanoes exhaled carbon. Rain drew it back to the sea. Every act of balance came at a cost. The blue sky we call natural is only the latest compromise in a long series of fragile truces. Even now, that balance can be broken. When we release carbon dioxide into the air, we are, in a sense, calling back the ancient red world, a slow return to the haze our ancestors escaped. Scientists warn of global warming, but perhaps what we are truly summoning is memory. The planet's instinct to return to its earliest comfort. The red sky was never gone. It was only buried beneath the centuries of blue. To watch a modern sunset is to witness the entire history of air compressed into a single moment. As the sun dips, the blue fades and red returns, a reminder that the past still breathes in the present. The same scattering that once painted the whole sky crimson now visits only in twilight, like an old song played briefly before night. If one listens carefully at dusk, there's a peculiar quietness that falls, as though the world pauses, remembering itself. The last light bleeds across the horizon, and for a heartbeat, the atmosphere glows as it did billions of years ago. That's when it's easiest to believe that the planet is still dreaming, that it never truly left its red sky behind. Perhaps the color of the early Earth is not gone but hidden in us, in our blood, our pulse, the rust that coats forgotten tools. Every red thing is a relic of that first atmosphere, a secret connection to a time when light and chemistry were still learning to dance. And when the last breath of daylight turns the world crimson again, maybe what we're seeing is not an ending, but a remembering. The Earth briefly recalling the warmth of its first home, before the air turned clear, before clarity began to cost so much. There was a moment when the Earth forgot how to breathe. The air grew thin, the ocean stilled, and sunlight dimmed to a cold whisper. From pole to pole, ice began to spread, creeping over continents, swallowing seas. The planet, once red and steaming, turned white. They call it the Snowball Earth, a name that sounds almost innocent, but it was a silence deeper than extinction. It was the time when the world nearly froze to death. It happened more than once. Around 720 million years ago, during the Cryogenian period, glaciers reached the equator. The entire planet became a single, glittering mirror, reflecting sunlight back into space. Temperatures plummeted to 40 degrees below freezing. The oceans froze hundreds of meters deep, trapping what little life remained beneath solid ice. The blue world we know became a crystal sphere, turning slowly in the dark. The evidence lies in the rocks, layers of glacial till found in regions that were once tropical, their stones rounded by ice. Drop stones, carried by floating glaciers, fell into ancient marine sediments in places that should have been warm. In Namibia, in China, in Canada, the same signature appears. The pattern is global, unmistakable. Something catastrophic happened. Something that defied all previous rhythms of climate. Scientists still argue over what caused it. Some blame a decline in greenhouse gases after the Great Oxygenation event. Others suggest that continents clustered near the equator, reflecting more sunlight, or that volcanic activity slowed, starving the air of carbon dioxide. Whatever the reason, the feedback loop was merciless. The colder it grew, the more ice formed. The more ice formed, the more sunlight was reflected. Within millennia, the Earth sealed itself inside a tomb of light. Imagine standing there, if standing were possible. The horizon would be endless white beneath a faint pink sky. The air would bite through stone. Mountains, buried in glaciers, would groan and crack with pressure. The ocean beneath the ice would be dark and dense, layered with brine and stillness. The moonlight would reflect off the frozen surface so brightly that it would erase the stars. Even the wind would sound muted, trapped beneath the weight of silence. Yet even in that stillness, life did not vanish. Beneath the ice, near volcanic vents and fissures, microbes endured. In cracks where light could not reach, they fed on sulfur and chemical heat, the last embers of a fading world. Some scientists think small patches of open water may have persisted around volcanic islands or equatorial upwellings, thin corridors of survival. From those refugees, life waited. It is possible that everything alive today descends from those few survivors hidden beneath a frozen sky. The Snowball Earth was not a single event, but a cycle. Freeze and thaw, death and rebirth. When the planet was finally released, it was by fire. Volcanic eruptions broke through the ice, pouring carbon dioxide into the air for millions of years. Slowly, the greenhouse returned. The ice melted, flooding the continents, drowning the glacial plains. The ocean surged back to life, rich with nutrients from eroded rock. The world thawed, but it was no longer the same. After the melt came an explosion of creativity. The Ediacaran life forms appeared soon after, soft-bodied creatures drifting like petals across the sea. It is as if the Earth, having nearly ended, began to dream again. Some scientists even suggest that the stress of those frozen ages forced evolution forward, that life adapted to survive extremes, learning resilience at a cellular level. The snowball may have been a crucible, not a coffin. But what if the story runs deeper? Some geochemists argue that the planet has a kind of memory, that each catastrophe imprints a pattern on the cycles that follow. The isotopes in ancient rocks show rhythms, the pulse of oxygen, carbon, and sulfur through the atmosphere. As though the Earth were breathing slowly, forgetting and remembering itself across eons. The snowball was one such breath. A long, frozen exhale before the next awakening. If you look closely at the geological scars, you can still trace its retreat. The cap carbonates, strange, rapid deposits that formed when the ice melted, lie atop glacial layers like signatures of resurrection. Their isotopic ratios suggest that carbon dioxide levels rose to 300 times those of today. The meltwater carried minerals into the oceans, fueling algal blooms that changed the chemistry of the sea. From those blooms came new life, complex, multicellular forms, the ancestors of everything that would later crawl, swim, and think. But the thaw also brought chaos. The rapid warming released methane from the ice, destabilizing the climate. Storms of unimaginable force swept across the newborn oceans. The planet oscillated wildly between freeze and fever. Life was reborn, but it trembled in the aftermath. It had survived, yes, but survival had changed it. After that, nothing living would ever again be simple. There's a strange beauty in the idea that the world's coldest moment prepared the way for its greatest diversity. The ice that nearly killed life also preserved it, shielding it from ultraviolet radiation and asteroid impacts. Beneath that frozen armor, biology refined itself, waiting for the right conditions to bloom. It is a reminder that creation often hides in catastrophe, that what looks like ending is sometimes only preparation. Some philosophers of science have compared the Snowball Earth to the concept of cosmic renewal. The universe itself cooling, condensing, and reigniting. The same cycles of death and rebirth that shape galaxies seem to echo in our own planet's crust. Perhaps there is no difference between the laws that govern stars and those that govern ice. Both are acts of forgetting, followed by memory's return. And still, the question lingers. How many times has Earth done this? Some evidence hints that even earlier global glaciations occurred, perhaps as far back as 2.9 billion years ago. Each time, life endured. Each time, it emerged changed. The planet has never been constant, only cyclical. Maybe stability itself is the illusion, the pause between extremes, not the rule. If the Earth could speak, what would it say about those ages of silence? Would it remember the weight of ice pressing down on its seas, the way light fractured through the frozen air? Or has it chosen to forget, carrying only the echo of cold in its winds? Perhaps the auroras that shimmer at the poles today are a memory of that age, the sky remembering the color of its own captivity. When we watch glaciers today, cracking, melting, retreating, we are not just witnessing climate, we are watching memory in motion. The ice still holds bubbles of that ancient air, the breath of a world that nearly ended. Inside those bubbles lies the soundless voice of deep time, the frozen whisper that says, I have died before. I have woken before. And somewhere, beneath miles of rock and ocean, the planet still carries that rhythm, the slow heartbeat of freeze and thaw, silence and song. The snowball world was not the end of life, but its baptism. And perhaps, when the Earth grows tired again, it will remember that old peace, the quiet sleep under ice, the long luminous dream of starting over. After the frozen ages melted away, the Earth began to breathe again, slow, deep, and green. Forests rose for the first time, reaching into a sky that had never known shade. This was the Carboniferous period, around 359 to 299 million years ago, an age when the planet exhaled life as if in relief after too many ages of silence. Everything about that world felt exaggerated, swollen, almost too alive. The air was heavy with oxygen, far richer than today, nearly 35%, enough to make every spark a potential fire, every breath a little dizzy. The planet had become a greenhouse of abundance, and yet beneath that verdant calm, another kind of transformation was already beginning. Imagine walking through those forests. The ground would be soft and damp, a carpet of moss thicker than any soil. Towering above you would be the trunks of lepidodendron and sigillaria, trees that were not truly trees, but giant relatives of club mosses. Their bark shimmered with geometric scales, their branches divided in fractal symmetry, reaching toward light filtered through layers of mist. Ferns the size of small houses spread their fronds over stagnant pools. Dragonflies with wingspans of 70 centimeters drifted like paper kites through the thick air. Millipedes longer than a man coiled through the ferns. Even the insects seemed to breathe in slow motion, their bodies swollen by the richness of oxygen. The forests were not silent. Beneath the canopy, amphibians croaked and splashed in swampy shallows, some as long as crocodiles. They were the first vertebrates to live between water and land, their slick skins glistening under a permanent twilight haze. This was a world of humid heat and endless growth, a time when decay could not keep up with creation. Plants piled upon plants, layers of life falling into water and mud, never fully decomposing. Over millions of years, those buried forests became coal, the compressed memory of green abundance, trapped in black stone. Every lump of coal we burn today is a piece of that age. Sunlight from 300 million years ago turned solid. It holds the breath of those forests, the exhalations of dragonflies, the hum of leaves long gone. When we light it, we release that ancient air again. A resurrection both literal and tragic. The Carboniferous dream still powers our modern world, and in doing so, it slowly brings back its heat, its humidity, its fever. But back then, it was paradise. The balance between photosynthesis and decay filled the air with oxygen, feeding fire and life alike. Lightning storms were frequent, and wildfires would sweep through the forests, but the plants grew back faster than they burned. It was a world that healed too quickly, a planet caught in a loop of exuberance. In the shallow swamps of what is now Europe and North America, the continents were still drifting together, forming Pangaea. The seas teemed with crinoids, brachiopods, and ammonites, spiraling shells that glittered like ornaments. The shorelines pulsed with tide and life. On land, the first seeds evolved, a quiet revolution. No longer did plants depend on water to reproduce. They could carry potential across dry ground. Life was learning permanence. And yet, every paradise carries its own shadow. The very success of the Carboniferous forests changed the planet's balance. So much carbon was trapped underground in peat and coal that the atmosphere thinned of greenhouse gases. The world began to cool again. Ice crept back into the poles. The giant insects shrank as oxygen levels fell. Amphibians gave way to reptiles, creatures with dry skin, capable of surviving in the growing aridity. The age of green abundance ended, as all abundance must. Still, what it left behind was immense. The coal beds, stretching across continents, became not just fuel but record. pages of sediment recording ancient rhythms of flood and fire, growth and decay. Inside those seams lie fossils of ferns so delicate their veins are visible, seeds still embedded in amber sap. The air of the Carboniferous, trapped in bubbles within the coal, tells us how sweet it must have smelled. A mixture of rot, resin, and rain. Scientists studying those forests have found strange patterns in their growth rings, signals of light cycles disrupted, perhaps by ancient climate swings or changes in the planet's rotation. Even then, the Earth was restless. The continents shifted, mountains rose, and the once endless wetlands began to dry. As rivers carved through the thick peat, ecosystems collapsed into one another, recycling themselves into new forms. The dream began to dissolve. There is something almost human about that age, a reminder that creation and destruction are always intertwined. The same forests that filled the air with life also buried their own memory beneath the soil. The coal seams became both tomb and testament, the Earth's diary written in pressure and flame. To dig into them is to read the story of generosity turned into consequence. If you listen closely to the wind that moves through modern forests, you might still hear echoes of that lush breathing. Every rustle of leaves, every drop of rain evaporating into mist, is a miniature version of the Carboniferous rhythm, the great inhalation of the Earth. Our planet has never again reached that level of oxygen, that luxuriant saturation of life. It was a one-time experiment, perhaps too extravagant to last, and yet, through its downfall, something enduring was born. The reptiles that replaced the amphibians carried within them the secret of survival. Waterproof skin, eggs that could live on land. They would give rise to the first dinosaurs, the first birds, the first mammals. Every creature that walked or flew afterward carried the memory of those swamps in its blood. Sometimes I think the Carboniferous wasn't just an era. It was a mood. A slow hallucination the Earth fell into after too many cold centuries. It dreamed of infinite growth, of green light and endless breath. And like all dreams, it burned out when it went too far. The coal that fuels our machines, our homes, our cities, is that dream's residue. We live inside its afterglow, and we are slowly awakening to its cost. In the end, the Carboniferous world teaches one quiet lesson: that abundance without decay becomes its own kind of death. Life must return what it takes, must exhale what it inhales. The forests forgot that for a while, and so they became fossils. We, perhaps, are forgetting it again. When the last dragonfly of that age landed on a cooling fern and the wind shifted toward cold, the Earth must have felt a strange peace, as though it had sung its most beautiful song and was ready for silence. Beneath the soft decay of those forests, the seeds of the next world waited, buried in carbon and time. And even now, when you hold a piece of coal in your hand, it's warm for a reason. You're holding the compressed memory of sunlight, of rain, of an Earth that once believed it could live forever. Before the first dinosaur left its print in the mud, another kind of kingdom ruled the Earth, vast, strange, and forgotten. It was the Permian period, the final age of the Paleozoic world, when evolution reached a fevered complexity before it all collapsed. The continents had gathered into one, Pangaea, a giant landmass surrounded by the endless Panthalassic Ocean. Across its deserts and coasts moved creatures that looked like nothing that came before or after, forms half mammal, half reptile, forged in the long shadow of the Carboniferous forests that had just died away. The Earth of that time was not green and humid anymore. The great swamps were gone, replaced by wide plains of red dust, rivers winding through sunburned valleys, and forests of conifers, cycads, and seed ferns. The air was still rich, but drier now, sharper, filled with the smell of resin and volcanic ash. The world was reorganizing itself. Life had learned to survive without water. It could now walk freely across the bones of the land. Among the rulers of this forgotten empire was Dimetrodon, with its iconic sail rising like a fin from its back. For decades, it was mistaken for a dinosaur, but it lived almost 50 million years before them. That sail, a network of spines connected by thin skin, may have helped it regulate temperature. Or perhaps it was a display, an early form of visual language. Its eyes were forward-facing, its teeth curved and serrated. It hunted amphibians and smaller reptiles in river deltas under a blazing sun. Dimetrodon was not a reptile, but a synapsid, a lineage that would one day give rise to mammals. There was Inostrancevia, a saber-toothed predator that roamed the Permian plains of what is now Russia, its jaws wide enough to crush bone, its gait heavy but sure. There was Gorgonops, named after the mythical Gorgons of ancient Greece, fierce creatures with eyes that seemed too intelligent for their time. There were also herbivores like Moschops, thick-bodied, with faces built for grinding tough vegetation, and Periosaurus, lumbering giants whose skin carried bony plates like natural armor. They moved slowly through forests of seed ferns, their bodies casting long shadows in the low ochre light. It was an age of experiments, nature testing ideas it would later abandon. Some reptiles learned to glide, others grew tusks. Amphibians grew massive, adapting to both water and land, but never quite belonging to either. The earth was restless, filled with movement and sound. The hiss of wind through fern fronds, the crackle of lightning in dry air, the low thunder of distant volcanoes. But even then, the seeds of ruin were taking root. Beneath Pangaea, the planet's mantle was shifting. Great volcanic provinces began to awaken. The crust thinned, cracked, and bled lava in volumes the modern imagination can barely contain. For millions of years, eruptions from what is now Siberia poured magma over the land, an area greater than all of Western Europe. The air darkened, ash blotted out the sun. The earth heated, then suffocated. It began slowly, too slowly for the creatures who lived through it to realize. Carbon dioxide levels rose. Rain became acid. The seas grew toxic, their oxygen drained. The coral reefs, which had thrived for hundreds of millions of years, dissolved. As temperatures climbed past thresholds no species had known, ecosystems unraveled. Forests died. Rivers stagnated. Even the insects, the most resilient life of all, disappeared in great numbers. In the oceans, things were worse. Methane, trapped for ages beneath the seafloor, began to release as the waters warmed. The gas intensified the greenhouse effect, pushing the planet into a runaway fever. Sulfate-reducing bacteria thrived in the oxygen-starved depths, releasing hydrogen sulfide, a gas that rose into the atmosphere and turned the sky green. Acid rain fell over continents stripped of leaves. It was not a single catastrophe, but a symphony of endings. When it was over, more than 90% of all species were gone. Entire families of creatures vanished without descendants. The trilobites, those patient witnesses of hundreds of millions of years, perished at last. Coral reefs disappeared for millions of years. The once teeming seas were quiet, pale, and empty. On land, the great synapsids, the ancestors of mammals, nearly followed. And yet, a few small forms endured. Tiny burrowing creatures, close to the ancestors of true mammals, survived in the shadows, perhaps underground, perhaps in cooler regions spared the worst. Their resilience became the bridge between two worlds, the age before and the age after. It is possible that every mammal alive today, from the smallest shrew to the largest whale, descends from those survivors. The Permian extinction, the Great Dying, was the closest Earth has ever come to wiping its slate clean. It reset the biosphere so completely that even the chemical composition of the oceans changed. The boundary it left in the rocks is visible everywhere. A dark line rich in carbon, a grave marker pressed into stone. Above that line, life starts again, hesitant, simplified, as though learning to breathe for the first time. What makes this extinction different is that it didn't come from space. It came from within. The planet turning against itself, its own heat and gases suffocating its children. It's a haunting mirror of the present, a reminder that the most powerful forces of destruction are not always foreign but internal. For the Earth, the Great Dying was not just an end, but a purification. In its wake came a new kind of world, a world that would give rise to the first true dinosaurs, to crocodiles and turtles, to birds and mammals. But the memory of that catastrophe remains, etched into every genome. Some scientists argue that even our stress responses, the way living things react to heat, to fear, to scarcity, are echoes of that ancient trauma. Life remembers. When paleontologists unearth fossils from that age, they find bones that seem almost mournful. Massive skulls with empty eye sockets, ribs warped by disease, jaws frozen mid-bite. The layers of ash around them are rich in soot, a sign of global wildfires. It's as though the whole planet had burned its forests in a single breath, and yet, above those ashes, new fossils appear. Small, unassuming, defiant. Early archosaurs, ancestors of dinosaurs and crocodiles, crawling through a world stripped bare. Tiny cynodonts with whiskers and warm blood, hiding in burrows, waiting for the heat to pass. From that desolation came the blueprint for the next creation. The Permian world is gone, but its lesson endures. That even when everything breaks, something endures the breaking. The monsters of that age, the gorgon faces, the sail-backed hunters, live on not as bones, but as echoes, in every creature that survived fire and hunger and thirst. If you look long enough at the fossil of Dimetrodon, you can almost see it breathing again. Sunlight glinting off its sail, steam rising from its nostrils, eyes scanning a horizon that no longer exists. It stands not just as a relic, but as a question. How many times can the Earth die before it forgets how to live? Maybe it never forgets. Maybe that's what makes this planet different. It keeps dreaming, even through its nightmares. And sometimes, when the wind moves through stone deserts, or when lightning flashes over an empty plain, it feels as though the Permian still exhales beneath the crust. A low, ancient bray. When the last volcano dimmed and the final waves of ash settled over the continents, the Earth fell quiet. It was a silence no living thing had ever known. Not the peace that follows storm, but the emptiness that comes when sound itself forgets its purpose. Forests had burned to dust. Rivers had boiled and dried. The ocean, once green with life, was now gray and still, its waters thick with death. After the Great Dying, the Earth became a mausoleum. It is difficult to imagine what the world looked like in those first million years after the Permian extinction. 90% of all species were gone, and the survivors wandered through landscapes that seemed almost alien. The land was bare, the soil thin, the air heavy with carbon and sulfur. The seas, stripped of oxygen, became acidic and lifeless, their surface calm, but their depths poisonous. The coral reefs had collapsed, leaving the coastlines naked and eroded. Even the insects, the constant hum of life that had survived every catastrophe before, were silent, The rocks from that age tell the story better than words can. In many places, the boundary between the Permian and Triassic layers is dark and glossy, a band of carbon-rich clay that marks the moment life stopped. Above it, the sediments are pale and empty, almost sterile. Fossils are rare, scattered, and small. It is as though the planet itself forgot how to create, but life, even when invisible, is persistent. In the shallows of what is now South China, microscopic algae began to bloom again. Cyanobacteria returned to the coasts, forming mats of slime that covered rocks and tide pools. These microbial colonies, humble and ancient, were the same kind of organisms that had once oxygenated the world billions of years earlier. It was as if the Earth had reset itself to the beginning. The clock of life started over, one cell at a time. For several million years, the planet stayed sick. The atmosphere pulsed with swings of carbon dioxide and methane, and the climate seesawed between heat and frost. Rain fell black with ash. Lightning flashed constantly, igniting barren plains where nothing remained to burn. The oceans remained sluggish and toxic, layered with hydrogen sulfide, a chemical that smells of rot and suffocation. But within that poison, a few species found ways to live. Tiny bivalves and ammonites returned to the coasts. Worms tunneled through the mud. Small fish, fragile as paper, darted between shadows. Life whispered again. On land, the survivors were few and strange. The synapsids, the mammal ancestors who had ruled the Permian, were nearly gone, reduced to a handful of species. Among them were the Lystrosaurus, a squat, tusked herbivore with a face like a turtle and lungs that could endure thin air. It became one of the most successful creatures in the early Triassic, spreading across almost every continent. Paleontologists have found their fossils everywhere, from Antarctica to South Africa, India to Russia. For a brief, lonely age, the Earth belonged to them. The forests that grew after the fire were sparse, dominated by hardy conifers and ginkgos that could tolerate drought. Ferns spread quickly in the disturbed soils, their spores carried by the wind. The landscape looked half-formed, patches of green scattered over vast deserts of red stone. There were no true ecosystems yet, only scattered survivors learning how to coexist. Evolution, once a symphony, had become a whisper of recovery. Scientists studying this recovery have noticed something haunting. The rebound was slow, far slower than after any other extinction. It took almost 10 million years for life to regain its previous diversity. For comparison, after the asteroid that killed the dinosaurs, ecosystems flourished again within a few million years. But after the Great Dying, the Earth seemed reluctant, cautious, as if afraid to trust its own breath. One reason may have been the instability of the environment. Volcanic activity continued for millions of years, releasing more gases into the air. The ozone layer weakened, letting ultraviolet radiation scorch the surface. Acid rain kept soils infertile. In some regions, even after the skies cleared, the oceans remained anoxic for millennia. The Earth was alive, but it was not well. It was healing, but with scars too deep to fade. And yet, from that prolonged silence came something extraordinary. The Triassic world that followed was unlike anything before. Out of the emptiness, new forms emerged. Creatures with lighter bones, quicker metabolisms, sharper senses. The reptiles diversified again, giving rise to the first archosaurs, the ancestors of dinosaurs, crocodiles, and birds. Small lizards learned to glide. Early amphibians evolved into new, sleek predators. Even the first mammals appeared, no larger than mice, hidden in burrows. Life had not just survived, it had reinvented itself. In a way, the Earth's pause was necessary. Without that long silence, there might never have been space for new ideas. The extinction had cleared the canvas, and what grew afterward was bolder, faster, more complex. It is the paradox of catastrophe, that sometimes the only way to move forward is through erasure. When scientists model the recovery of the biosphere after the Permian extinction, they find a pattern like breath. Collapse, pause, surge. The pause lasted millions of years. A planetary inhale. Then, suddenly, diversity exploded again in the Middle Triassic. Coral reefs returned, new forests spread, and animals began to fill every niche once more. It was the Earth's slow exhalation, a sigh of relief after almost dying. Still, that silence lingers somewhere in the planet's memory. The fossil record between the Permian and Triassic feels like a blank page, a space of mourning between chapters. And maybe that is why the Triassic world, when it finally arrived, felt so feverish, so driven to evolve. The planet had seen how fragile life was, and seemed determined never to fall that far again. Some philosophers of geology call this pattern punctuated breath, the idea that the Earth lives through intervals of suffocation and renewal. Each mass extinction is both an ending and a rehearsal. The survivors carry the memory of loss in their genes, shaping the next generation's resilience. In that sense, the silence after the fire was not emptiness but incubation. The Earth was thinking. When we look at the rocks of that age today, we can still smell the soot, the faint trace of burned forests mixed with the mineral scent of new beginnings. It is the perfume of rebirth, harsh but honest. Somewhere beneath our feet, in the layers of Triassic sandstone, lies the line where silence turned to sound again. Sometimes I wonder if the planet itself grieved, if it felt the absence of voices, the missing songs of creatures that would never return. Perhaps that grief is what drove it to create again, to fill the void with new forms of beauty. And maybe, when we walk through deserts where the rocks are red and cracked, when we hear the wind move like breath through canyons of stone, we are hearing the echo of that ancient silence, the long exhale after the world burned, the whisper of life remembering how to sing. In the long quiet after the great dying, the Earth began once more to dream. The silence that had stretched for millions of years was slowly replaced by the sound of water moving, wind returning to the forests, and the hesitant rustle of new life. This was the Triassic, the age when the planet, fragile and wounded, tried to live again. It did not roar back to life all at once. It trembled awake, cautious, like someone rising from a nightmare still unsure that the dawn is real. The continents were still fused together, bound in the vast supercontinent of Pangaea, surrounded by a single global ocean. The climate was extreme, deserts the size of continents, coastlines battered by monsoon rains, and endless plains where heat shimmered like glass. Yet within this harshness, something delicate was beginning. The air, after millions of years of poison, was breathable again. The seas, once acidic and lifeless, began to cradle coral and fish. Ferns spread over the empty ground like soft bandages covering old wounds. The Earth, for all its scars, was learning the art of recovery. The first new animals to return were small and unassuming. Amphibians with flattened heads, fish with lungs, lizards no longer than a hand. But among them, something remarkable was evolving. The reptiles that survived the extinction began to diverge, forming two great lineages. The Archosaurs, who would one day give rise to dinosaurs, birds, and crocodiles, and the Synapsids, the ancestors of mammals. From this fragile split, two futures began to unfold: the age of giants and the age of thought. At first, the Triassic world looked barren. Fossil soils from this time show little organic matter, almost no humus, a sign that vegetation was thin and scattered. Yet when the rains came, the barren earth turned green almost overnight. Plants that could tolerate drought and heat, cycads, horsetails, and seed ferns, painted the landscape in muted shades of olive and rust. In the river valleys, forests began to rise again, slender and uncertain. The wind through their leaves must have sounded like a new kind of music, and with that, music came movement. Archosaurs appeared first as small, agile predators. One of the earliest was Euparkeria, a reptile from South Africa that could run on two legs when it needed to. Its limbs and hips were the blueprint for all dinosaurs that would follow. In its quickness, in its hunger, the future was already taking shape. Over the next 20 million years, the descendants of such creatures diversified into every niche. The long-necked Plateosaurus, the armored Desmatosuchus, the crocodile-like phytosaurs with their nostrils atop their heads. The Earth was sketching, revising, perfecting, but it was not only the reptiles that found their rhythm again. The first true mammals, small, warm-blooded, nocturnal, began to emerge in the shadows of these giants. Their bones were delicate, their bodies covered in fur, their senses keen. They were survivors' children, cautious and clever. Their ancestors, the cynodonts, had lived through the extinction by burrowing into the ground. Now they surfaced, carrying within them a new invention. Differentiated teeth, faster metabolisms, and the first glimmers of parental care. They were still tiny, living beneath the notice of larger creatures, but they held a secret none of their rivals possessed: endurance through intelligence. The Triassic sky, too, was different, clearer now, washed clean by millennia of volcanic rain. Lightning still rumbled over the deserts, but the clouds that formed carried promise instead of ruin. The red earth glowed under the sun. At dusk, as the temperature fell, the air filled with the low calls of insects, the croaks of amphibians, and the chirr of primitive cicadas. To stand there, on that recovering planet, would have been to feel time itself breathe again. Still, the Earth remained unstable. Volcanism continued along the edges of Pangaea, releasing heat and ash. Droughts came in waves. There were brief extinctions, setbacks along the way, but compared to what had come before, these were mere tremors, not endings. Life had learned a kind of resilience, a stubborn refusal to vanish. Every extinction became smaller, every recovery faster. The planet was practicing survival. In the seas, ammonites, those spiral-shelled wanderers, returned in abundance, coiling like galaxies in miniature. The coral reefs rebuilt themselves, made now of new species better adapted to fluctuating conditions. Fish diversified, sharks reclaimed their thrones, and marine reptiles, ichthyosaurs and nothosaurs, evolved sleek, hydrodynamic forms that sliced through the water like memory reborn. Some of them grew immense, precursors to whales in shape if not in blood. The ocean, which had died in green suffocation, began to glitter again with life, and yet the shadow of the great dying lingered. The chemical scars in rocks tell us that the carbon cycle remained unstable for millions of years. Carbon dioxide rose and fell wildly, as if the planet was still gasping, unable to find its rhythm. In some places, fossilized soils show cracks and salt crystals, evidence of drought and sudden floods. Life, though returning, lived at the mercy of volatility. It was a fragile balance, and one that would soon be tested again. At the end of the Triassic, roughly 201 million years ago, another wave of volcanic eruptions shook the world. This time, it was the Central Atlantic Magmatic Province. A series of fissures that opened as Pangaea began to split. The eruptions released enormous amounts of carbon dioxide, triggering rapid warming and ocean acidification. Many species disappeared once more, including the large amphibians and several reptilian lineages. Yet from that chaos, the dinosaurs, small, adaptable, and already waiting, rose to dominance. It is easy to read this as fate, but it was not destiny, only persistence. The creatures that inherited the earth were not the strongest, but the ones most attuned to change. They could survive in heat, endure drought, and migrate when the world moved beneath their feet. The Triassic taught life how to bend instead of break. The strange thing about this period is how incomplete it feels, like a bridge between worlds. The fossils are fewer, the layers thin, but within that sparseness lies something profound, the first true sense of motion in evolution. The Earth, after pausing in grief, was moving again. Each creature, each leaf, each wave carried the momentum of rebirth. If the Permian extinction was a scream, the Triassic was a sigh, a breath drawn slowly, painfully, but filled with hope. The planet had proven that it could come back from death, though not without cost. Every species that survived carried the memory of fire and suffocation, encoded not in words, but in instinct. The will to adapt, to seek shelter, to flee, to hide, to start again. When we look at that world now, through stone and fossil and isotope, what we see is not just survival, but forgiveness. The earth forgave itself, piece by piece. The rivers ran again. The forests grew. The air cleared. The sea sang. It was a slow healing, but healing all the same. And when the first true dinosaurs finally began to walk the newly split continents, they did so over the graves of millions of forgotten ancestors. Creatures who had burned, drowned, suffocated, and endured so that life could try again. In their shadows, the story of the planet turned another page. The Triassic world was not paradise. It was scar tissue, radiant under the sun. But from that scar came everything that would follow. The thunder of herds, the flight of birds, and much later, the quiet wonder of those who would look back and try to remember how the world began again. By the time the Triassic world had ripened, the earth had become quiet again. Not empty this time, but calm, like a creature finally breathing without pain. The scars of the great dying were buried beneath new forests. The oceans were blue again, and the air had turned light, almost transparent. Across the vast stretches of Pangaea, rivers carved silver paths through green valleys, and the sky shimmered in a steady warmth the planet hadn't known in millions of years. Everything, at last, was still, but in that stillness, something was waiting. Evolution rarely rests for long. Beneath the roots of cycads and ferns, among burrows where small mammals hid, the earth was already rehearsing its next act. The air smelled of pine and damp clay. The light was golden and slow, diffused by a thin haze that made every shadow gentle. If you stood there, in that ancient morning, after so many ages of silence, you could almost feel the world exhale. Along the banks of shallow lakes walked the new inhabitants, small, graceful reptiles with slender limbs and alert eyes. Colophasis was among them, a creature neither large nor fierce, but quick, watchful, perfectly tuned to the new rhythm of the earth. In its stride was a confidence the planet had not seen since before the fire. Every movement it made seemed to whisper, "Life remembers how to move forward." Above the plains, the sky belonged to wings for the first time. The earliest pterosaurs glided over the rivers, their fragile frames catching currents of air that still smelled faintly of ash. They looked like thoughts, fleeting, weightless, as though the world itself was dreaming of freedom. At night, when the heat faded, their silhouettes vanished into a horizon filled with stars that mirrored the ancient ocean below. The forests, too, had learned new languages. Conifers reached higher, their needles drinking sunlight. Ferns carpeted the ground in thick patterns of emerald and bronze. Insects returned in delicate abundance, their buzzing weaving invisible threads between trunks. Every leaf seemed to hum softly, as if the forest itself was remembering the melody of existence. And within that abundance, new hearts began to beat differently. The small mammal-like cynodonts had survived in shadows through the great silence, but now they stirred, their fur catching dew, their bodies warm from within. They had learned something none of the old monsters knew: how to make heat from hunger, how to carry life inside themselves when the cold came. In their tiny, rapid heartbeats, the future was hiding. Fur, thought, tenderness. The ocean, once poisoned and still, now shimmered with vitality. Ammonites spiraled through clear water, ichthyosaurs breached like silver arcs under sunlight, and reefs bloomed again in pastel hues. Schools of fish glinted like moving constellations. If you could sink beneath the surface, you'd see the seafloor alive with coral gardens, and currents swirling with plankton that glowed faintly in the dim light. The same ancient rhythm that had begun billions of years ago, still pulsing, unchanged. The continents themselves were shifting again. Deep below, the planet turned in slow tectonic sleep, setting in motion the next fracture of Pangaea. What had once been one land would one day become many, but that future was far away. For now, the Earth was content in its unity, a single breathing world, stitched together by silence and wind. There were storms, of course, there always are. Lightning danced across the plains, and thunder rolled over the deserts, but even the violence felt purposeful now. Fire no longer meant ending, it meant renewal. The rains that followed were warm and fragrant, seeping into soil rich with the remains of worlds before. And from that soil rose every color life could imagine. In that fragile peace, time itself seemed to slow. For the first time since the planet's birth, life existed not in panic or in struggle, but in equilibrium. Every creature fit. Every sound had space around it. Even the light seemed to know where to rest. It was a brief and perfect harmony, the pause between one breath and the next. And yet, there was memory. In the stones, in the salt, in the bones of the living, the memory of extinction lingered. The earth never truly forgets. Each sunrise carried within it the echo of red skies and frozen silence. The oceans still tasted faintly of ash. Even the wind, gentle as it was, carried dust from continents that had burned long ago. Perhaps that's what made the Triassic world so beautiful. Its beauty was haunted. Every creature, every wave, every gust of wind carried the knowledge that this peace was temporary. The planet had learned that survival was not the absence of death, but the courage to rise after it. When the first true dinosaurs appeared, small, alert, and luminous under the late Triassic sun, the Earth did not tremble. It watched. These new beings were different, bones light but strong, minds tuned to rhythm and distance. They walked in silence across the wet ground, their reflections trembling in shallow pools. The air around them seemed to shimmer. The world was ready for movement again, for thunder in the soil. And somewhere in the underbrush, the small mammals watched. They did not compete or flee. They simply observed, their eyes bright with curiosity, their bodies warm and quiet. They would wait their turn, They always did. Above it all, the sky stretched vast and forgiving, no longer red, no longer choked with ash, but wide and blue, the color of release. Clouds drifted like memory. Sunlight traced slow arcs across the forests. The planet had made peace with itself, at least for now. If you could stand there, in that calm between ages, you might hear something beneath the wind, a pulse, faint but steady, like a heart too deep to measure. It is the sound of the earth remembering. Every cycle, every extinction, every rebirth, none of it was wasted. Life was not simply surviving. It was keeping record. The mountains, carved by forgotten seas, held the stories of oceans that no longer existed. The air itself was layered with memory, of fire, of frost, of breath. And perhaps, if you closed your eyes, you could feel it too. That subtle recognition between you and the ground beneath your feet. The same minerals in your blood were once dust in those storms. The same oxygen you breathe was born from ancient seas. You are, in a way, the continuation of that memory. The earth dreaming through you, and as the sun sets over that quiet, forgiving world, the wind carries a whisper that sounds almost human. Remember me, but do not mourn me. The light fades into gold. The shadows stretch long, and somewhere in the distance, a lone creature stands at the edge of the forest, unmoving, as if listening to the echo of time itself. The day ends gently. The sky darkens into infinite blue. The earth once again is waiting for whatever comes next.